Okay, so the first thing we're going to talk about today are S block elements. Remember we talked about how you can look at the periodic table as different elements or different families or different periods, which are all very good ways of looking at the periodic table, or we can look at them as blocks. And so today we're going to talk about the different periodic blocks. So the first block we're going to talk about are the S block elements. And S block elements have some unique relationships. The first thing they have are diagonal relationships. Yesterday we were talking about relationships in families, how families have similar trends in relationships. S block elements have some diagonal relationships so in addition to their horizontal and vertical trends, they have a diagonal relationship between such as lithium and magnesium, beryllium and aluminum, boron and silicon, where they have the adjacent upper left, lower right relative location on the periodic table. I'm going to show you what they look like in a minute. But basically, this says that elements within these diagonal relationships have closer properties to the element in the diagonal relationship than the next one in their own group. I'm going to show you what that means. So if we're looking at a periodic table, lithium is more closely related to magnesium in terms of properties and trends than lithium is to number 11. And I've pulled up a periodic table this morning for this very reason, and I've hidden it behind my computer. So just 1 second. Sodium. I was right, but I wanted to make sure. As in, sodium is more likely to be closer to calcium than it is to potassium, and potassium is more likely to be related to strontium than it is for rubidium. So we're going to look at S block as in hydrogen, because hydrogen is officially part of the S block. So is helium officially, but hydrogen isn't really part of the alkali metals or the alkaline earth metals. So we talk about hydrogen individually. And hydrogen is officially in group 1, that's the alkali metals, as it has 1 valence electrons, but it does not have any of the same properties of the alkali metals. In fact, it was discovered in 1766 by a man called Henry Cavendish. He called it flammable air because to him, it looked like air that was flammable. And a really cool fact is that universe contains more than 90% hydrogen by mass, meaning 90% of the mass in the universe is hydrogen. And the single valence electron is the reason of hydrogen's usual properties, because it has a set of both metallic and non-metallic properties. Hydrogen is a very unique element. Then we have the group 1, which is the alkali metals. The reason that they're called alkali metals is 2 different reasons. One, they react with water to form alkaline solutions. And the word alkali in and of itself comes from the Arabic word alkili, meaning ashes of the saltwort plant. They very easily lose their valence electrons. They always want to form a cation with a 1+ charge. They're very easily cut with a knife. They are found combined with other elements in nature. They're very good conductors of both heat and electricity. And when we start looking at electron configurations, they are S1. If you're wondering what the most important information to write down is or to study, I have bolded it for you. Although I can promise you the meanings of word is always a favorite of me to put onto tests. Then let's talk about group 2. These are the alkaline earth metals. Earths are from a really cool reason. If you know anything about medieval alchemy, which was basically medieval doctors, not quite doctors, like pharmacists, those who tried to heal, but maybe didn't know that much, they believed that a lot of disease was caused by an imbalance of your earth, air, fire, water, and that's what you had in your body. You had earth, air, fire, water. And if it was an imbalance, then you got sick. Therefore, almost everything that they looked at, they felt represented one of these elements. And because they could not burn them in their fires, they classified them as earths. Please do not ask me why it wasn't water. That would have made much more sense to me, but earths, I guess, didn't burn either. So they were our earths because they couldn't get burned. So alkaline earth is also reflective of two of the following properties. Alkaline, it forms an alkaline solution with water. And earth, it reacts with oxygen to form an oxide. It is less reactive than group 1. They're usually found with oxygen and other non-metals in the Earth's crust. They always lose 2 valence electrons with bonding, forming a 2+ cation. I'm going to put that, they form a 2+ cation. Their charge is 2+. Then when exposed to oxygen, alkaline earth metals form a thin oxide coating. And when we're looking at valence electron configurations, they are s2. And then if we're going to move forward, the big things we're going to talk about, column 1 is S1, and its charge is 1+. Column 2 is S2, and its charge is 2+. Those are very important things to know. We will be moving back and looking at this information in a different way in a couple of units and even in a couple of days, but getting that basic information down so you can either label a periodic table or start memorizing what things are is an important thing. I don't want to, I want you to see it multiple ways in different ways. And that is the S block.